Welcome to Lesson 3-10, when dividing is also multiplying. This is part 1 of a two-part lesson. Today we're going to be talking about division of fractions, and we're going to be showing you how dividing fractions is really like multiplying fractions. Here we have a picture of a banana, and we have 3 people. What I want to do is divide my banana up equally into 3 people. If I were to divide the entire banana up so that I could give it equally to 3 people, I would just simply break my banana into 3 equal parts. Then we could see that each person would get 1/3 of the banana. But if I wanted to, say, cut my banana in half, and now give half of my banana to 3 different people, I would have to take my half of a banana and cut it into thirds. Drawing 2 lines to cut it into 3 equal pieces. Now let's show a division problem to show how I could divide this half of a banana equally amongst 3 different people. So my division problem would look like this. Half of a banana divided by 3 people. We know that with multiplication, we can't multiply with whole numbers. That's going to remain true with division. We don't want to divide with whole numbers. So we can turn our whole number into 3/1. So now we have a half of a banana divided by 3 people, and the division problem is 1/2 divided by 3/1. We can see obviously here that if we do divide this half a banana amongst 3 people, each person is going to get 1/3 of the half. Remember what I just said. Each person is going to get 1/3 of a half. 1/3 of 1/2. Now I want you to be aware right away that when you look at our 2 problems right now, our division problem and our multiplication problem, we see that we have the very similar factors. We have a half over here, we have a half here. We have 3/1 here, and we have the exact opposite, 1/3 here. Both of these equations make sense when you read them. We're taking a half a banana here and dividing it amongst 3 people. And here we're saying that each person is going to get 1/3 of a half of a banana. Both expressions are written correctly and both mean the same thing. So right here we can see the relationship between division and multiplication and how close that relationship is. Now I'm going to have you recall that multiplication is commutative. The commutative property of multiplication says that you can reverse the numbers and you will still get the same product. So I'm going to take our multiplication problem and reverse it. I'm going to change it to 1/2, and I'm going to change that of to a multiplication sign. And I'm just reversing my factors because I'm allowed to. And now we can see that they're still closely related, and even closer now. The 1/2 factor is now in the same exact place. The sign, again, is just the opposite. And if you take a look at the second factor, 3/1 and 1/3, you see that there is a relationship there. What is the relationship between 3/1 and 1/3? They look almost the same, except they are the exact opposite. So because I'm telling you that these are the same, I'm going to show them to you. 1/2 divided by 3 is the same as 1/2 times 1/3. Now take a look at both of these expressions and figure out exactly what I did to my division problem to turn it into a multiplication problem. Well, one thing that I did for sure was I changed the sign, and I changed it from division to multiplication, which is the opposite. So I changed the sign to its opposite. The next thing I did was I took my 3, which is really 3/1, and I changed it to its opposite. What's the opposite of 3/1? Well, flip it, and you will see the opposite is 1/3. This is how we're going to be dividing our fractions. We're not going to divide them, in fact. We're going to be changing the sign to its opposite, and then changing the second factor only to its opposite. That's called the inversion. When we invert a fraction, If I ask you to invert a fraction, that means to flip it. Invert or flip. And when you do that, it's called the inversion. So 1/3 is the inversion of 3/1. Or we inverted it. Or we flipped it. Now turn to workbook page 91 and follow along with me. Page 91, we have a question here that says there are 4 people in the Walton family, but there are only 3 waffles. How can the Waltons share the waffles equally? Well, each person is going to get 1/4 of each of the waffles. Every waffle that we have up here, 1, 2, 3 of them, has to be broken up into 4 equal pieces, and each person, 1, 2, 3, 4, is going to get 1/4 of each one. So if that is true, and there are only 3 waffles, each person is going to get 3 of the fourths. This person will get 1 of this fourth, 1 of this fourth, and 1 of this fourth. Therefore, they will have 3/4 of a waffle. And each other plate will also be taking 1 from each one. So this person will get 1 from here, 1 from here, and 1 from here, which is 3/4. The third plate will get 1 from this plate waffle, 1 from this waffle, and 1 from this waffle, 3/4. And the final plate gets 1 from this waffle, 1 from this waffle, and 1 from this waffle, or 3/4. Really what we're doing here is we're dividing our 3 waffles into 4 equal plates. And they've shown the equation right here, 3 divided by 4. They've also shown the relationship between the division problem and the multiplication problem. What they've really done here is they've taken their 3 divided by 4 and they've changed that into 3/1 divided by 4/1, because we don't divide or multiply fractions when we have whole numbers. But here we have 2 whole numbers that we're dividing, 3 divided by 4. Well, 3 divided by 4 usually can't be done. It can be done using decimals, but we haven't learned that yet. So you can see that 4 won't go into 3. So it's not a bad idea to change it to a multiplication problem, and then we'll get a product that's a fraction. So this is what they're doing. They're keeping their first factor the same. The first factor is 3/1. That is not changing. It's still 3. And this whole number is the same as 3/1. But they are changing the sign from division to multiplication to its opposite. And when you do that, you need to also change something else. You can't just change a sign and have the problem be the same. 2 plus 1 is 3. 2 minus 1 is 1. You can't get away with that. So if you're going to change the sign from its division to multiplication or to its opposite, then you need to make the next factor its opposite as well, or invert it. 4/1 is inverted to 1/4, or we flip it. And when you do that, you have 3/1 times 1/4. And then we just multiply straight across as we've been doing. 3 times 1 is 3, and 1 times 4 is 4, and that's how we end up with 3/4. So let's suppose there are 5 people and 4 waffles to split. So we could write our equation. You could also draw an extra waffle up here if you wish, and an extra plate, and work the problem out with pictures. Or you can write out the problem, write an expression that shows 4 waffles divided into 5 people. And when you do that, knowing that that's a difficult problem to do, we can switch this to a multiplication problem. 4 divided by 5 is not using any fractions, but it can be turned into a fraction problem, the same as 4/1 divided by 5/1. We can do that. And then we can take the next step to turn this into a multiplication problem, because remember, we never divide fractions, we always multiply them. So it would be the same as 4/1 times changing our division problem to its opposite, multiplication. And whenever you do that, then the very next factor needs to be inverted. So we're going to do that by flipping it, or inverting it, into 1/5, its opposite. And now they're exactly the same problem. 4 now times 1 is 4, and 1 times 5 is 5. So each person will be getting 4/5. Each person will be getting 4/5. And we can complete our equation down here. They've already written the 4 divided by 5, which is the same as 4 times 1 over 5. And that 4 becomes 4 over 1, and then multiply straight across, and you get 4/5. Now I'd like you to pause the video and do number 2 on your own, and then come back and we'll finish up this page. Still on page 91, number 3, I will model it for you, and then you will do number 4 on your own. Number 3 is 5 divided by 6. We're going to convert this to a multiplication problem. We're going to show how it's the same as a multiplication problem. It's the same because 5 divided by 6 will the first factor will remain the same. That will be 5 as well. But the sign is changed to its opposite from division to multiplication. Therefore, the next factor has to be inverted or changed to its opposite, and that will become 1 over 6. The reason why is because it's the opposite of 6 over 1. The 5 over 1, by the way, is shown here as a whole number. It should be turned into a fraction as well. And then we multiply straight across. 5 times 1 is 5, and 1 times 6 is 6. Complete questions 4, 5, 6, and 7 now on your own, and come back and we'll complete the second page of today's lesson. Pause the video now. We're on page 92 of your workbook now, and on number 8, they're asking how many 8s, ironically, are there in 1. This is a really simple problem, actually. We have one whole here. So we have 1, and we're going to divide it into 8s. Wonder how many 8s we can get out of a whole. So we just write the expression 1 divided by an 8th. And we know that we don't divide fractions, so we're going to turn this into a multiplication problem. We're going to keep the first factor the same. That's going to stay the same, still going to be 1. But we're going to change the sign to its opposite. And we know that whenever we do that, the next factor has to be changed to its opposite as well. So we're going to flip it or invert it. Use the word invert a lot, so make sure that you understand what that means. And so when we do that, we now can multiply 1 times 8, which is 8, and 1 times 1, which is 1. And that's an improper fraction, so our answer then is going to be 8. Pause the video now and complete number 9 on your own. Question number 10 says, why can you also use multiplication equation 3 times 8 equals 24 to show how many 8s there are in 3? Well, we can see our 3 holes right here. And we can see that each of those holes are cut into 8s. So we can tell that because each hole is cut into 8 different parts, that if we just take 3 times 8 parts for each one, it'll tell us how many parts there are in total, which is 24. Now pause the video and complete number 11 and 12 on your own. Number 13 says Olivia made 9 sandwiches and cut each one into fourths. How many fourths does she have? Well, she started with 9 sandwiches and she divided those sandwiches into fourths. So it's essentially 9 divided by 1/4. 9 sandwiches divided by fourths. You can imagine if you had 9 sandwiches and you cut each one into fourths, that you would end up with more than 9 sandwiches. You could feed a lot more people by cutting them each into fourths. Of course, drawing pictures is one way to solve this problem. And now you could just count up your fourths, and you would find that you would have 36 fourths. But we want you to show it as a division problem, an expression, and also convert that to a multiplication expression. 9 divided by 1/4 is the same as 9 times 4 over 1. Again, because our first factor stays the same, our division problem changes to its opposite, the multiplication problem. And our second factor then must be inverted, or change to its opposite, which is 4 over 1. And 9 times 4 equals 36 over 1, which is the same as 36, which is the same as what you would get if you added up all your 4s. Now I'd like you to pause the video and complete questions 14 through 16 on your own. Now that you've completed all of your questions, if there's anyone else at your table that is complete, you may collaborate with them, go over the answers to 14, 15, and 16 together, and help each other out, make sure that you have the correct answers.